Welcome back to Mastering C++20 Features. In this lecture, I will give a very basic introduction about C++20 ranges library. So without further ado, let's begin. The goal of the very first lecture on C++20 ranges is to give a brief overview of the C++20 ranges library with some motivating examples. In this lecture, I will show briefly with examples how the ranges library enable a clean syntax for manipulating containers, how it helps to alleviate common errors that can happen when using STL algorithms, and majorly, how ranges library enable us to compose algorithms in less lines of code compared to STL algorithms. As I mentioned earlier, this lecture is only a brief overview of the ranges library. I will dive deeper into the C++20 ranges in the upcoming lectures. So here's the first example with classical STL algorithms. I have an array of 6 integers on which I want to run a sort, and then I want to find an element out of the input array. Using the classical STL algorithms stdsort and stdfind, one needs to use the begin and end iterators on the array. This is nothing but boilerplate code. This is cumbersome compared to other modern languages. This makes the code look very cluttered, and the intent of the code is rather hard to find by simply glancing over the line of the code. With C++20 ranges algorithm, the sort and find looks like this. Note the range version of the sort and find algorithms are in the namespace std ranges. With the new ranges algorithm, one can see directly that there's no need to use the begin and end iterators associated with the array, and consequently the code becomes really expressive and clean, and the intent of the code is conveyed in one glance. But that's not the only benefit of the ranges algorithm. Let's see more in next slide. STL algorithms can be error prone and buggy if one is not careful. For example, here's a function that returns R value of a container. If one is not careful and does the following in the code, that is, call the getVector function with respective begin and end iterators directly within the STL algorithms, it can lead to errors. Can you spot the bug in this example? You can pause the video and try to think. Well, since we are using getVector function twice directly within the stdsort, each returning an R value of the iterator, and when using begin and end iterators on two different R values, the iterators are not comparable. This can lead to potential runtime errors such as incorrect answers from the STL algorithms. However, if the compiler warning levels are set correctly, then the compiler may warn or also result in an error. But the use of compiler flags is unfortunately not always an option, especially in production code. With C++20 ranges, however, since we do not need to call begin and end iterators, we can use one single PR value of the container within the ranges : sort algorithm, and this will work. Thus, the opportunity to write buggy or error-prone code in general is reduced with the ranges algorithm. The final motivating example I wanted to share with you in this lecture is about composability with the ranges algorithm, which, by the way, is not so straightforward with the classical STL algorithm. Composing algorithm actually means using the output of one algorithm as an input to another algorithm, which usually is done by chaining the algorithm together. For example, suppose if you had an array of numbers and you wanted to use few elements from that array, let's say only the odd numbers, and using those odd numbers you wanted to perform some computation, let's say cubing those odd numbers, then with classical STL algorithms, one would have to do this in multiple steps, which would require at least one temporary variable and multiple lines of code. And if the number of computation one has to perform on the element increases, then it becomes challenging to compose the algorithm. Let's look at this example in the code editor. Here I have a file open where I first demonstrate the example with STL algorithms. Note in line number 4, I am using the locally installed FMT library to leverage the feature of directly printing the contents of a container with ranges. You can also install this library from this website fmt.dev. In line 6, I have defined my first callable odd, which returns true if a given number is odd, else it returns false. And in line 7, I have defined another callable, which is a lambda function, which simply cubes the number that it gets as a parameter. Now, as shown in the last slide, if I have an input array of numbers on which I want to get the array of numbers that are cubes of the odd numbers of the input array, then with C++ STL algorithms, I need to first filter out the odd numbers and store it in a temporary array, and then I have to compute the cube of the odd numbers that was stored in the temporary array. Let me first type the code that we need, and then I'll start explaining. I'll start typing the code in the main function. Next, I have to use an STL algorithm to filter out the odd numbers from the input vector into my temporary vector called temp. For this, I will use std_copyIf algorithm and use the odd predicate that I declared in line number 6. Along with this predicate, I will also need to use the std_backinserter algorithm to insert the result of this filtering into the temporary vector in the correct order. Let me type this and show you how it is done with the STL algorithm. Now I will finally attempt to cube the element in the temporary array and store the result in the result vector that was declared in line number 14. For this, I will use STL's std transform algorithm. Note here again I need to use the std_backinserter to insert the elements in correct order into the result vector, and I need to use the unary function called cubed that I declared in line number 7 to transform the provided number into its cube. So let me type this here and show you how. Finally, let's print the elements of the result vector on the console using the format library that I included in line number 4. You can see how nifty the print function from the FMT library is. It can directly print the array on the console without me having to use the for loop. So let me compile this code and run the executable. Here I already have my compilation command ready on the console. Now I will run the compilation command and we can see the result on the console. We can see that all the odd numbers have been cubed, and these odd numbers are actually the odd numbers that were filtered out from the input element. If you do not have the FMT print library, you can also use the for each algorithm in the ranges library. Let me show you how you can do this. So we got the same output on the console using the ranges for each algorithm. This is different from STL's for each algorithm because we did not have to use the begin and end iterator on the input array. So in summary, I had to use a temporary array to store the temporary result, and I had to use begin and end iterator using the STL algorithm, and additionally I had to use the std_backinserter to insert the elements in the correct order into the result and the temporary vectors. So the usage of STL algorithm requires a bit more awareness than one would expect out of a modern language. Honestly speaking, before creating this video lecture, I myself did not completely remember how to use std_copyIf and std_transform algorithm, and had to refresh my knowledge on STL algorithms, which I hope I don't have to do very often again in the future. Now let's see how we achieve the same result with C++20's ranges algorithm. For this, I will remove all the lines of the code. I will remove this, get rid of the for each. I will, however, retain the fmt print line to be able to print my result again on the console. Now to use the ranges library, we need to scope the ranges algorithm with std ranges, name of the algorithm. However, we can create an alias to std::ranges to be quick and save some typing effort. Let me type this namespace alias here. Additionally, I also need the views algorithm here, which also happens to be under the namespace ranges. So I will type out the namespace alias for views. But the namespace alias for views can also be written like this. Now coming back to our computation, to get the same result with std ranges algorithm, I have to type only one line of code. Let me do that here. Now if I again compile the code and run the executable, I think I'm missing a header. Here we go. We get the same result as with the STL algorithms. To use the views algorithm, we must always include the correct header, which is the ranges header. And then you can notice how I have got the result of my computation in only one line of code. There are a couple of points to note in this line. Firstly, I have used the algorithm from the namespace ranges: views. Ranges and views are both important additions of C++ ranges library. Both ranges and views have differences in terms of how they execute and behave and their return types. However, since this is just an introductory lecture on ranges, I will explain the views algorithm in detail later in the series. Second point to notice is how I changed the algorithm with the help of the pipe operator. If you are familiar with the shell and bash scripting, you might have already used the pipe syntax to chain the operations together. This pipe operator, which is a new operator in C++20 between the input vector and the views filter, as well as between views filter and views transform, helped us to avoid any kind of temporary variables in the computation. Also notice the absence of begin and end iterators in this one line of code. Isn't this so convenient? When reading this one line of code, the intent is conveyed very clearly. We are trying to filter out the odd numbers from the input vector, and then on this filtered odd number, we are transforming the elements into the cube of the numbers. Although this is a new way of programming as well as thinking with C++, once we get used to the pipe operator with C++20 ranges algorithm, the chaining of complex operation becomes fairly easy. So here's a summary of all the points that I discussed in the coding example. In the next lecture, I will dive deeper into C++20 ranges and discuss more deeply which of the STL containers available in C++ standard can work with the C++20 ranges algorithms. Thank you and see you in the next lecture.